Hey guys, welcome to another in episode of organic naming in the wonderful world of chemistry. So what you'll notice over here is on the left side, I've got my flowchart. On the right side, I've got this review document. So the plan for today is just kind of go through the review document. Feel free to skip over this stuff if some of it seems familiar. How it's going to work is I'm going to go over the questions I've circled first. These are the questions that we're asking you on the little daily assignment for today. So hopefully that'll clarify everything else. And then I'll just kind of go through the rest of this stuff. So let's start with the first question. First question's asking, what's the maximum number of bonds that a carbon will have? So if we look over here at an example of one of our carbons, here is pentane. You'll notice that it has 5 carbons, and every single carbon, notice, has 4 lines coming off of it. So when we're asking ourselves, hey, how many bonds is carbon going to have? It's going to have 4. Right, that's pretty standard. So that can mean, 4 single bonds, that can mean 2 double bonds, that can mean a double bond and 2 single bonds, a triple bond and a single bond, a whole bunch of different things. Pretty much everything other than just like a quadruple bond, because we don't see those happen. For the prefixes, pretty much what it's asking you to do is to copy this guy down from right over here, where it's all the prefixes from the organic flowchart. So hopefully you know, for example, that 1 is meth, 2 is eth, 3 is prop, and kind of so on and so forth. But I'm actually going to skip that for now. Let's go down to kind of the first question that it asks. 6A is one of the questions that we're asking on the review. And it says, name the molecule and identify the group they belong to. On the quiz, I just asked you to name the molecule. So the key here is that we see there's a O double bonded to 2 kind of carbon chains. So this to me looks very similar to this kind of a setup where we have some R group, some R group on one side bonded to an O, and then an R group on the other side of a different length. So we might even call that R prime. So this is an ether. So I would definitely write down ether. And then remember, we end the name always with ether, so I'll also put that in just because I can. And it looks like we've got 1, 2, 3, 4, 5 carbons on the one of the sides, so that's pent. And then we've got 3 carbons on the other side, so that's prop. Now, I might have got this wrong on one of the quizzes, so I switched it. But pent, PE, comes before PR. Obviously, I'm not exactly great with the alphabet. But so it should be pentyl propyl ether. Hopefully you guys at this point in time can just kind of know what an ether looks like without necessarily referring back to this guy over here. Cool. Next question was 6C. So we'll go ahead and we'll work on that now. This is a 2, 4, 6 carbon chain. So right away I can call that hex. And then we'll notice that the key little functional group here is a C double bonded to an O. So C double bonded to an O, there's kind of 2 things that have that. We've got our ketones and we've got our carboxylic acids. In this case, there's no OH. We don't see that there, so it's got to be a ketone. So it's going to be hex, oops, and then it'll end in ANONE. Kind of following the rest of this flowchart, we know that it's hexanone because it's got carbons on each side, and then we have to include a number here, just kind of following the arrows. So it looks like this carbon, or the functional group is on the second carbon, kind of 1, 2, counting from left to right. So we would call this 2-hexanone, and this, of course, would be an example of a ketone. Cool. Okay, moving on here. Now we have to name stuff, which is a little bit more difficult. The first one ends in YNE, so YNE means we're going to have to include a triple bond somewhere. Prop means 3 carbons, so 1, 2, and 3 carbons right there. And then we have to include a triple bond on the first carbon. You could either put it on either side, it doesn't really matter. But then the tricky part here is going to be making sure, okay, where exactly do I put the bonds? So let's be careful here. This middle carbon already has 4 bonds. This outermost carbon only has 1 bond, so it's going to need 1, 2, 3 more. And then this other outermost carbon already has 3 bonds, so it's just going to need 1 more bond. So it should look like that, more or less. And then it just becomes an issue of filling in the H's. So that right there is 1 propyne. Pretty easy. The next question for F is butanol. But means 4 carbons, 1, 2, 3, and 4. Anol means, what does that mean? Oh, alcohol. An alcohol is an example of something that ends in ANOL. So I have to pick the second carbon. In this case, I'm just going to pick this guy to put an OH on. Second, either way, right? You can from the left or from the right. And then it's just an issue of making sure that every carbon has 4 bonds coming off of it. And well, bam, there it is. They all have 4. And then just kind of filling in the H's to make it beautiful. Okay, so that was all of the questions that were like on the quiz. I'm just going to use the rest of this time now to kind of take care of the rest of this worksheet. So feel free to keep watching if you have questions on other things, or I don't know, if you feel comfortable with this stuff. Hopefully you're ready for the test. All right, let's keep going. I'm actually just going to get rid of this thing. Let's just focus on this. Oops, close. Okay. There, that's a little bit better. Meth eth prop 4 is but, but. 5 is pent. 6 is hex. 7 is hept. 8 is oct. Non and dec. Okay. Ooh, this is a good question. Saturated versus unsaturated. Unsaturated means it's got double or triple bonds. Oops, I think I spelled triple wrong. Triple bonds. And saturated means everything is all single bonds. So just to throw an example at you, something like, I don't know, C, 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 we'll put 3 C's here. Something like this would be unsaturated, and then something like this would be saturated. So it's easy to get those switched up. I don't know, sometimes people mess that up. Please don't mess that up. Okay, moving on. General formulas for carbon, for alkanes. Let's start with alkenes. That's the easiest one. It's CnH2n. That's the easiest one to remember. So if you have 6 carbons, you'll have 12 hydrogens. For alkanes, what we do is it's CnH2n, but then it's also plus 2. Because keep in mind here, you have like 2 carbons, or 2 hydrogens, one on top, one below every carbon, and then the outermost carbons also have an extra hydrogen. So that's how I remember it. And then for alkynes, it's CnH2n minus 2, just because you're losing a total of 4 hydrogens from a alkane. Okay, this would be really easy if you were looking at your flow chart, but you know, on a test you probably won't be able to do that. So here we go. OH, we're thinking alcohols. And then remember, R is just a group of carbons, so it could look something like this. And then, of course, there'd be a bunch of hydrogens on all of the carbons. I'm not going to take the time to draw them out, but that's kind of the general idea. This right here with a double bond is called an alkene. With a triple bond, we call that an alkyne. F and A kind of look fairly similar, don't they? We got an O bonded to an H versus an O bonded to another R. So the difference between that is an alcohol, but this guy is called an ether. So ethers, remember, they have carbon chains on either side, so it would look something, you know, like this. And then, of course, all the carbons have bonds to hydrogens coming off of them. Yeah, something like that. Let's Let's make these a little bit smaller, just so they're a little less in the way. Cool. Okay, this next one over here, notice that it is a C double bonded to an O, but then notice that there's little R groups on either side there. So it's not a carboxylic acid. Instead, it's going to be what we call a ketone. So yeah, a couple things I would mention about this. Ethers look very similar to alcohols, just because they both have an O with, two bonds on the other side. And ketones look very similar to what the general formula for like a carboxylic acid would be, where it would look like this. Again, very similar. There's just kind of that one slight change. This would be carboxylic acid. Cool, cool. All right, we named the first one. This second one over here, B, is an alcohol. I know that because it's got an OH, so then it's just an issue of counting up all the carbons. How many of them do we have? 7, 8, 9. Oh, okay, it is 10. So 10 is dec, and then it's going to be ANOL. And then since this OH falls on the first carbon, we would call it 1-decanol, and we'd say it's an alcohol. Cool. All right, for this next one, again, start with cutting off the carbons. 5, 6, so hex. And then it's kind of nice, this one doesn't have anything on it. There's no special functional groups or anything. They're just all kind of, single bonds. So this is just hexane. And we would call that an alkane. Kind of nice, kind of easy. For E, we've got a triple bond right here. So we'll just have to watch out for that. Triple bond means we end in YNE. And then we've got 1, 2, 3, 4 carbons. So it'd be butene, and it looks like this triple bond starts between the first and the second carbon. So remember, it's wherever it starts, so it'd be 1-butene. And remember again, outside to in, that's how we number stuff. F looks a little bit different than something you might have seen before, but this has a C double bonded to an O and then an OH. So that is a carboxylic acid. Carboxylic acid. Oh, by the way, the previous problem was an alkyne. Cool. So carboxylic acids end in anoic acid, and then whatever comes in front is just how many carbons we have. So in this case, we got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 carbons. Notice that I counted this carbon here. Sometimes people will forget to count that. They'll think the carbon's a part of the functional group, so they don't have to count it. That's wrong. You do have to count it. 8 is oct, so octanoic acid is what we're looking for. Cool. Oh, it's kind of weird for G. You see one hydrogen down below and one hydrogen up top. That can totally happen. It's actually called like a cis versus a trans organization of hydrogens. They can either be both up top, that's cis because they're the same way, or they can be opposite, that's trans because they're opposite. Anyways, fun little chemistry fact. 1, 2, 3, 4, 5, 6, 7 carbons. We would call that pent, or no, we wouldn't call that pent, that's 5. We would call that hept. Hept is 7. And then since it's a double bond, we'd call that ene, so heptene, and it looks like it starts on that third carbon. And that's not true for both ways. It's either the third carbon or the fourth carbon. Remember, we take the lower number, so it'd be 3-heptene, and we would call this an alkene. Okay, drawing structures. Let's switch this up a little bit. Let's use blue to draw the rest of these structures. Nonane is just going to be 9 carbons, so bear with me while I draw all them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then every carbon just gets either 2 hydrogens if they're in the middle, or 3 hydrogens if they're on the outside. I'm not going to bother actually drawing all of these H's, but you can just see kind of where the bonds would go for each one of the H's there. I'm just going to kind of leave it there. That's a cool little shortcut you can do. Propanone. Prop has 3 carbons. Prop 1, 2, 3. Now anone means double bonded O, and in this case it's going to fall on the second carbon. Be careful here. because nothing goes underneath this carbon. Notice it already has, you know, it already has 4 bonds. So we can't put a hydrogen below the carbon with the double bonded O. Butyl hexyl ether, this is going to be a lot again. Remember, an ether is an O. But means 4, 3, 4. Just fit that in there. And hex means 6, 3, 4, 5. That's 5, 6. And then again, I'm just going to draw the bonds, but I'm not actually going to take the time to draw all of the H's. Close enough. All right, there should be another like bond on the other side of this guy over there. But anyways, okay, to octene. Let's do the last one there. Octene is 8 carbons, 4, 5, 6, 7, 8, and then yeah. Let's just draw octane first. Okay, 2 means on the second carbon, so that's this guy right here. So I'm just going to replace 2 of those single bonds and replace them with a double bond. And then for this one, I'm actually going to take the time to draw in all the H's just so you can see where the H's are and also where the H's are not. Okay. Anyways, that's the review worksheet. I hope you had fun looking over this with me. Hopefully you learned something. Let me know if you have any questions about any of this. I did kind of go through this pretty quickly. Again, thanks for watching. Have a great